Hello and welcome to our video presentation on techniques of differentiation in calculus. So we are excited to take you through some key concepts and examples to help you understand how differentiation works and how it can be applied to solve problems. Before we begin, let us introduce ourselves. We are from AS120 students and our team members are: first we have Arena Vera Akta over here. And secondly, it was me, Hilda Meni Anna Henry. And last but not least, to complete our group, we got Sabrina and Neola. So now let's get started by understanding what is differentiation really means in calculus. Let's get through to it for the explanation, which is presented by Arena Vera Akta.
What is differentiation? Differentiation is a noun showing differences. According to Cambridge University, the act of showing or finding difference between things that are compared. It is differentiation between something and something. For example, we make no differentiation between so-called high and low culture, and so on.
Hello, my name is Sabrina and I'm going to explain you this techniques of differentiation for calculus. There are 6 main techniques of differentiation often taught in more advanced or structured calculus courses as the follow, which I'm going to say. The first one is power rule. It is used to differentiate functions of the form x to the power of n, where n is any real number. The second one is product rule. It is used to differentiate the products of 2 functions. The third technique is quotient rule. It is used to differentiate the division of one function by another. The fourth technique is chain rule. It is used to differentiate composite functions, a function inside of another function. The fifth technique is implicit differentiation. It is used to differentiate equation where y is not isolated. The last technique, the sixth one, is logarithmic differentiation. It is used to differentiate complicated expression, especially those involving products, quotient, or powers. I'm going to explain question 1, which is explain the meaning of differentiation and what are the techniques of differentiation. First, what is differentiation? Differentiation is a fundamental concept in this topic, which is calculus, that deals with finding the rate at which function changes. For the techniques, there's 6 techniques altogether, which the first one is power rule. The equation is d over dx bracket x to the power of n equals to n x to the power of n minus 1. The second one is product rule, where the equation is d over dx bracket fx times gx close bracket equals to f prime x gx plus fx g prime x. The third technique is quotient rule, which the equation is d over dx bracket fx over gx equals to f prime x gx minus fx g prime x over bracket gx close bracket square close bracket to the power of 2. The fourth one is chain rule, which the equation is if y equals to fgx, then dy dx equals to f prime gx times g prime x. The fifth technique is implicit differentiation. For example, if x to the power of 2 plus y to the power of 2 equals to 1, then d over dx bracket x to the power of 2 plus d over dx bracket y to the power of 2 equals to 0, then 2x plus 2y dy over dx equals to 0, then it also means dy over dx equals to negative x over y. The last technique is logarithmic differentiation, which there's an example. For example, if y equals to x to the power of x, then take your ln y equals to ln x to the power of x equals to x ln x. And then you differentiate it, which is y 1 over y times dy over dx equals to ln x plus 1. Then it becomes dy of dx equals to y bracket ln x plus 1 close bracket, then equals to x to the power of x bracket ln x plus 1.
For question 2, we must find the dy dx to the following functions a and b. For function a, it is the product of y equals e to the power of 2x in function x squared plus 5x to the power of 3. Firstly, we must identify the components. U equals to e to the power of 2x and v is the function of x squared plus 5x to the power of 3. Since y equals to u times v, we'll use the product rule to find dy dx, which is dy dx equals to uv prime plus vu prime. First, we must differentiate u, which is e to the square of 2x. Then, it will become u prime equals to 2e in the power of 2x. Then, we will differentiate v, which is in function x squared plus 5x to the power of 3. This is a composite function, so we use the chain rule. Let w equals to x squared plus 5x, then v equals to w in the power of 3. The derivative of v with respect to x is 3 in function of x squared plus 5x squared in other function 2x plus 5. Next, we apply the product rule, which is dy dx equals to uv prime plus vu prime. That makes it dy dx equals to e to the power of 2x times 3 in function x squared plus 5x squared in function 2x plus 5 plus x squared plus 5 in the power of 3 times 2e in the power of 2x. Then we will simplify the expression, which turns out to be dy dx equals to 3e to the power of 2x in function x squared plus 5x squared in the function of 2x plus 5 plus 2e to the square of 2x in function x squared plus 5 in the power of 3. For question 2b, we must find the dy dx of y equals to the functions ln plus x plus 1 over sin 4x. Whereas u is the numerator, ln x plus 1, and v is the denominator, sin 4x. Once we identify u and v, we must find their derivatives. When we differentiate u equals to ln x plus 1, we get u prime equals to 1 over x plus 1. And when we differentiate v equals to sin 4x, we get v prime equals to 4 cos 4x. Then we apply the quotient rule, which we substitute u, v, u prime, and v prime into the rule of dy dx equals to vu prime minus uv prime over v squared. Then we simplify the expression. We get dy dx equals to sin 4x times 1 over x plus 1 times 1 minus ln x plus 1 times 4 cos 4x over sin 4x squared. Lastly, we get our final answer, which is dy dx equals to sin 4x over x plus 1 minus 4 ln x plus 1 cos 4x over sin squared 4x.
Okay, for my part, question 3, I'm going to explain how I got my answer. First of all, the given is 2y over e to the power of 3x minus ln x plus y equals to sec 2y plus 5x. First off, we would have to differentiate both sides, left-hand side and right-hand side. Starting with left-hand side, which is 2y over e to the power of 3x minus ln x plus y, we will add d over dx in front. So it will be d over dx times 2y over e to the power of 3x minus another d over dx times ln x plus y. Then we will get 2y prime e to the power of negative 3x minus 6y e to the power of negative 3x minus bracket 1 over x plus y times 1 plus y prime close bracket. Then it will equal to 2y prime e to the power of negative 3x minus 6y e to the power of negative 3x minus 1 over x plus y minus y prime over x plus y. That is for the left hand side. Moving on to the right hand side, d over dx bracket sec 2y close bracket plus d over dx bracket 5x close bracket equals to 2y prime sec 2y tan 2y plus 5. After that, after getting left hand and right hand side, we will then set both sides equal. 2y prime e to the power of negative 3x minus 6y e to the power of negative 3x minus 1 over x plus y minus y prime over x plus y equals to 2y prime sec 2y tan 2y plus 5. After that, we will have to group y prime terms together. 2y prime e to the power of negative 3x minus y prime over x plus y minus 2y prime sec 2y tan 2y equals to 5x equals to 5 plus 6y e to the power of negative 3x plus 1 over x plus y. And then we will factor y prime out, which is y prime outside the bracket 2e minus 3x minus 1 over x plus y minus sec 2y tan 2y close bracket equals to 5x plus 6ye minus plus 6ye to the power of negative 3x plus 1 over 2xy. For the final answer, we will put dy over dx in front equals to the left hand side above 5 plus 6ye to the power of negative 3x plus 1 over x plus y over the bottom is the right hand side 2e to the power of negative 3x minus 1 over x plus y minus 2 sec 2y tan 2y. That is the final answer. Thank you.
For question 4, which is linear approximation, here we are using linear approximation to estimate the value of a complicated expression, which is 4th root of 16.37 plus 1 over the square root of 16.37. We are going to find for derivative, which is fx equal to x power of 1 over 4 plus x power of negative 1 over 2. And then for the prime x, which is f prime x equal to 1 over 4 x power of negative 3 over 4 minus x power of negative 3 over 2. Next, we are going to pick for x equal to 16 because it's close to 16.37 and it's easy to work with. So delta x equal to 16.37 minus 16, which is equal to 0.37. We are going to calculate and evaluate the function, which is for fx. We are going to sub in x equal to 16 and f in bracket 16 equal to 16 1 over 4 plus 16 negative 1 over 2. So the answer for the fx is 2.25. Next, we are going to solve for f prime x, which is equal to f prime in bracket 16 equal to 1 over 4 in bracket 16 power of negative 3 over 4 minus 1 over 2 16 power of negative 3 over 2. And the answer is 3 over 128. And lastly, we are going to apply for linear approximation formula, which is fx equal to f in bracket x plus delta x and equal to fx plus f prime x multiplied by delta x, which is the answer is 2.2574. And we are going to round it to 2 decimal places, which is the final answer is 2.2574 equivalent to 2.26 in 2 decimal places. So in this presentation, we explore the fundamental techniques used to differentiate functions, from basic rules like the power and product rule to more advanced methods like the chain rule and implicit differentiation. So here we got 4, which is use the power rule for polynomials, product and quotient rules for combination of functions, and chain rule for nested function, and also implicit differentiation for equation that not solve for y. So mastering this technique make it easier to handle more complex problems in calculus and apply them across science, engineering, and economics. Differentiation isn't just about rules, it's about understanding how things behave when they change. So keep practicing, and over time this technique will become second nature.